Hello students, we have been learning the topic straight lines. In this topic, we have studied slope of a line, angle between two lines, collinearity of three straight lines, etc. Now let us study various forms of the equation of a straight line. Various forms of the equation of a line. First, let us see vertical lines and horizontal lines. Vertical lines. We see a line that is parallel to y-axis. We take the line as L and which is parallel to y-axis at a distance of a unit from the origin. We know that the line is perpendicular to x-axis. And the equation of this line, we write it as x is equal to a. That means x equal to a is a straight line which is parallel to y-axis and passing through the point x is equal to a of x-axis. If a is positive, then the line lies to the right of y-axis. So we studied that x equal to a is a line that is parallel to y-axis. We studied that x equal to a is a vertical line and that is parallel to y-axis. If we consider x is equal to minus a, then that is a line which is parallel to once again y-axis at a distance of a unit from the origin, but it lies the left of y-axis and it is passing to the point minus a or minus a0. So we have got two types of vertical lines. One is x is equal to a and another one x is equal to minus a. X equal to a lies to the right of y-axis and x equal to minus a lies to the left of y-axis. Move on to the next type of lines, that is horizontal lines. These are the lines which are parallel to x-axis. We have got a line here which is at a distance of b unit from the origin and the line is parallel to x-axis. The equation of this line is written as y is equal to b. Since b is a positive number, this line lies above x-axis. Similarly, if the line lies below y-axis, its equation is written as y is equal to minus b. That is, y is equal to minus b is a line which is at a distance of b unit from the origin and lies below x-axis. So, there are two types of horizontal lines, y is equal to b and y is equal to minus b. Y is equal to b lies above x-axis and y is equal to minus b lies below x-axis. Now we come to point slope form. We consider a line that is passing through the point a x1 y1 with slope m. Pxy is a general point on the line. Since the slope of the line is given to be m, we know that m is equal to y2 minus y1 divided by x2 minus x1. In this case, we have m is equal to y2 minus y1. We have y minus y1 divided by x minus x1. Cross multiplying, we get y minus y1 is equal to m into x minus x1. This is the equation of the required line. That is, we consider a line passing through the point x1 y1 having slope m. The equation of the line is given by y minus y1 is equal to m into x minus x1. Let us take an example. Find the equation of a line having slope 2 by 3 and passing through the point minus 1, 4. We know that m is equal to minus 2 by 3 and it is passing through the point x1 y1, that's equal to minus 1, 4. Our equation is y minus y1 is equal to m into x minus x1, or y minus y1 in this case, that is 4, is equal to m 2 by 3 into x minus 1. That is, y minus 4 is equal to 2 by 3 into x plus 1. Cross multiplying, we get 3y minus 12 is equal to 2x plus 2, or 2x minus 3y, bringing minus 12 to right hand side, we get plus 12, and 12 plus 2, that is equal to 14, is equal to 0. Hence, the required equation is 2x minus 3y plus 14 equal to 0. The next is 2-point form. That means the line is passing through two given points. Let x1, y1 and x2, y2 be the given points. We assume that slope of this line is equal to m. M is equal to y2 minus y1 divided by x2 minus x1. We know that y minus y1 is equal to m into x minus x1. Replacing m with y2 minus y1 divided by x2 minus x1, we get y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. This equation, we call it as the 2-point form of the equation of a straight line. So what is the 2-point form of the equation of a straight line? Y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Let us see an example. Equation of a line passing through the point 2 minus 3 and minus 1 0. Here x1 comma y1 is equal to the first point, say 2 minus 3, and x2 comma y2, that is the second point, that's equal to minus 1 comma 0. We know that y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1, that is y minus y1 in this case, that is minus 3. So it will be y plus 3 is equal to y2 minus y1, that is 0 minus minus 3. 0 minus minus 3, we can write 0 plus 3 divided by x2 minus x1, that is minus 1 minus 2 into x minus x1, that x1 is 2. On simplifying, y plus 3 is equal to 3 divided by minus 3, that is minus 1 into x minus 2. Again, y plus 3 is equal to minus x plus 2. Bringing to left hand side, we get x plus y plus 3 minus 2 equal to 0, or x plus y plus 1 is equal to 0. This is the equation of the line that is passing through the point 2 minus 3 and minus 1 0. Slope-intercept form. That means we have got a line whose slope is given to be m and y-intercept is c. Since the y-intercept is c, we know that the line is passing through the point 0, z. Slope is given to be m and y-intercept is c. Hence, the line is passing through the point 0, c. We take x1, y1 is equal to 0, c. We know that y minus y1 is equal to m into x minus x1, or y minus, in this case y1, that is equal to c, m into x minus 0. On simplifying the RHS, we get mx, the LHS is y minus c, or we write y is equal to mx plus c, which is known as slope-intercept form of the equation of a straight line. In the similar way, we consider a line whose slope is m and x-intercept is given to be d. That means the line is passing through the point d0. So slope is m and the point through which it is passing, that we take it as say x1 comma y1, that's equal to d comma 0. Therefore the equation y minus y1 is equal to m into x minus x1 implies y minus y1 in this case, that is 0, m into x minus d, or we write y is equal to m into x minus d. This is the second form of the equation, that is slope-intercept form. We have got slope-intercept form y is equal to mx plus c and y is equal to m into x minus d. Here c is the y-intercept and d is the x-intercept. The next is intercept form of the equation of a straight line. This can also be known as double intercept form of the equation of a straight line. We have got a line L whose x-intercept is given to be a and y-intercept is given to be b. Since x-intercept is given to be a, we say that the line is passing through the point a comma 0. Y-intercept is b, therefore the line is passing through the point b 0 b. We write x1 comma y1 is equal to a comma 0 and x2 comma y2 is equal to 0 b. We assume that slope of the line is equal to m. Slope is equal to m. We know that y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1, or y minus y1 in this case, that is 0, is equal to y2 minus y1 b minus 0 divided by 0 minus a into x minus a, or y is equal to minus b by a into x minus a, which implies ay is equal to minus bx plus ab, or bx plus ay is equal to ab. Dividing throughout by ab, we get bx divided by ab plus ay divided by ab is equal to 1, or x by a plus y by b is equal to 1, which is the required equation. Hence, intercept form of the equation of a straight line is x by a plus y by b is equal to 1. Let us consider a line L which is at a distance of p unit from the origin. Therefore, we have OP is equal to p. Let the perpendicular OP makes an angle omega with the positive direction of x-axis. We know that angle OPA is equal to angle OPB, and that's equal to 90 degree. Therefore, triangle OPA and OPB are right triangles. Since the given line meets x-axis at A and y-axis at B, we write the coordinates of A as OA0 and the coordinate of B as 0b. From triangle OPA, we have OP divided by OA is equal to cos omega, or P by OA is equal to cos omega. We write OA is equal to P by cos omega. Similarly, we write OB is equal to P by sin omega. That means we are taking two triangles OPA and OPB, in which OA is equal to P by cos omega and OB is equal to P by sin omega. Hence, we proved that OA is equal to P by cos omega and OB is equal to P by sin omega. We know that the line is passing through OA0 and 0, OB, x1 comma y1 is equal to OA comma 0, x2 comma y2 that's equal to 0 comma OB. The equation of the line is given by y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1, or y minus y1, in this case that is 0, is equal to y2 minus y1 OB minus 0 divided by 0 minus OA into x minus OA, or y is equal to minus OB divided by OA into x minus OA. Cross multiplying, OA into y is equal to minus OB into x plus OA into OB. Replacing the values of OA and OB, we get P by cos omega into y is equal to minus of OB, that is P by sin omega into x plus P by cos omega into P by sin omega. Dividing throughout by P, we get y by cos omega is equal to minus x by sin omega plus P by sin omega into cos omega, which implies multiply throughout by sin omega into cos omega, we get y sin omega is equal to minus x cos omega plus P, or we can write it as x cos omega plus y sin omega is equal to P, which is the equation of the straight line in the normal form. General equation of a straight line. Any equation of the form ax plus by plus c equals 0, where a and b are not 0 simultaneously, is called general linear equation or general equation of a line. Reduction of general equation into various forms. Say for example, we convert the general equation into slope-intercept form. We have got ax plus by plus c equal to 0. This can be written as by is equal to minus ax minus c, or y is equal to minus a by b into x minus c by b. That is of the form y is equal to mx plus c, where m is equal to minus a by b and c is equal to minus c by b. So we say that the slope of this line is minus a by b and the y-intercept is minus c by b. So any equation in the form ax plus by plus c equals 0 can be converted into slope-intercept form, that is y is equal to mx plus c. Next, intercept form. We have ax plus by plus c equals 0. This can be written as ax plus by equal to minus c. Dividing throughout by minus c, we get ax divided by minus c plus by divided by minus c is equal to 1, or it can be written as x divided by minus c by a plus y divided by minus c by b is equal to 1, which is of the form x by a plus y by b is equal to 1. Therefore, the x-intercept a, that's equal to minus c by a, and y-intercept b is equal to minus c by b. Therefore, the equation ax plus by plus c equal to 0 can be converted in the form x by a plus y by b is equal to 1, where a is equal to minus c by a and b equal to minus c by b. Normal form. Let the equation ax plus by plus c equals 0 or ax plus by equal to minus c can be written in the normal form as x cos omega plus y sin omega equal to p. Since equation at 1 and 2 are identical and equal, we write a by cos omega plus b by sin omega equal to minus c by p, a by cos omega equal to minus c by p, and b by sin omega equal to minus c by p, or cos omega is equal to minus ap by c and sin omega equal to minus bp by c. Squaring, we get cos square omega equal to minus ap by c whole square and sin square omega equal to minus bp by c whole square. Adding both the equations, we get cos square omega plus sin square omega is equal to a square p square by c square plus b square p square by c square. On simplifying, 1 is equal to p square by c square into a square plus b square, or p square is equal to c square by a square plus b square, which implies p equal to plus or minus c by root of a square plus b square. Substituting the values of p for cos omega, that is equal to minus ap by c, and sin omega equal to minus bp by c, we get cos omega equal to plus or minus a by root of a square plus b square, sin omega equal to plus or minus b by root of a square plus b square, and p equal to plus or minus c by root of a square plus b square. That means, if we need to convert the given equation into the form x cos omega plus y sin omega equal to p, then we need to divide throughout by root of a square plus b square in such a way that the RHS c by root of a square plus b square is positive. Hence, to convert ax plus by equal to minus c into a normal form, we need to divide throughout by root of a square plus b square by keeping the RHS positive, being the perpendicular distance. Let us consider an equation. (3x plus 4y plus 8 equal to 0. We write this as 3x plus 4y is equal to minus 8. In this case, a is equal to 3, b is equal to 4, and c equal to minus 8. We find root of a square plus b square. That's equal to square root of 3 square plus 4 square is equal to square root of 25 is equal to 5. Now, we need to divide throughout by plus or minus root of a square plus b square, that's equal to plus or minus 5, so that the RHS is positive. We know that the RHS is negative, so we need to divide throughout by minus 5. Therefore, we get 3 by minus 5 into x plus 4 by minus 5 into y is equal to minus 8 divided by minus 5, or we write minus 3x by 5 plus minus 4y divided by 5 is equal to 8 by 5, which is the normal form of the equation of the given line.